Very good morning to you, and you're welcome to today's Signpost webinar. We hope you're keeping safe and well wherever you're joining us from this morning. My name is Mark Gibson, and I'm the manager of the Teagasc Connected Programme. This series is brought to you by Teagasc in collaboration with Dairy Sustainability Ireland, the National Rural Network, and Food Drink Ireland SkillNet. So, all of the signs are pointing towards a low nitrogen future in agriculture. The EU Green Deal and Farm to Fork strategies are seeking a reduction of up to 20% in fertilizer usage by 2030. So what does this mean for commercial dairy farming in Ireland? Well, there is a beacon of light shining from a research farm based in County Tipperary, and I'm delighted to be joined by Dr James Humphreys, Principal Research Officer with Teagasc, who is going to talk to us today about commercial dairy farming without fertilizer nitrogen. Good morning, James. You're welcome to the series.
Morning, Mark.
A second time. It's great to have you back.
Yeah, almost a year now since the previous time.
Yeah. Where has that year gone? And Pat Murphy, good morning to you.
Good morning.
How's it all down in Wexford today?
Good. Nice sunny morning. A little bit cold, but no, it's good. All good.
Great. Well, thanks, Pat. You're going to help us with questions afterwards. So, James, as I said, welcome back. You're going to be talking to us today about the holy grail of commercial dairy farming without the use of artificial nitrogen. Is it possible?
Well, it's possible, and I guess I'll show the results of what we're finding. I suppose the key to this is like the big question is why you do such a thing, and the key to it is the lower environmental impact. As you said, the Green Deal, but I suppose the main motivating factors are, when we look at nitrogen, it's a source of nitrate leaching, it's a source of nitrous oxide, which is a very potent greenhouse gas, accounts for around a third of emissions from farms, and also a source of ammonia, which is subject to international agreements for mitigation or reduction. So there are the motivations for it. And of course, the challenge looking at 2030, particularly in terms of greenhouse gas emissions, the likely targets that are there, and how we can reduce those emissions on farms without impacting on productivity and profitability. And if you look at the various options, say you could cut numbers, for example, which will immediately impact on your production and your profit. Or you could look at, say, nitrogen fertilizer and using clover and things like that to replace it, and maintaining your output in that way.
And you have proven that this can be done in Solohead. You've been working on this for quite a number of years now, and you're showing really positive results around clover. What are the limiting factors, would you say, James, in terms of the uptake of clover across dairy farms in Ireland, or indeed farms?
I suppose there's two elements to that. One is kind of a lot of the work we've done can show that clover can work, not only in Solohead but also Clonakilty, Moorepark. And the economic benefits are maybe not as clear cut. Maybe they're becoming more clear cut now. I think a main driver for this will be more environmental than economics. And the second thing, so that if you had very clear economic advantage, clover then becomes very attractive. The other aspect is the management. And if we have a very well organized system of grassland management based on fertilizer and nitrogen, which is very cost effective, the incentive for a farmer to change practices are not there. You know what I mean? If you've been running a thing very well for many years, why would you change? It's a bit like saying, if you're used to driving a petrol or diesel car, why would you take on an electric car? Because it requires a change in how you go about your business, charging the thing up. You may have some limitations in terms of the distance you can travel. And I think you have a similar problem when you compare a clover type system to a nitrogen fertilizer based system.
Yeah.
So the motivations for taking on an electric car would be somewhat similar, if the analogy makes any sense.
I think that's a really good analogy. I mean, there's a change required, or a shift in behavior required that needs, and Pat, I'm sure you'll be able to tell us all about that with your electric car at some stage, your experience. Maybe we can dedicate a session to that one at some point.
Having a while, haven't had to worry about range anxiety because I haven't got very far, but maybe that'll come too.
I can picture a Jeremy Clarkson style show on Pat's experience with his electric car. Well, James, look, we better get stuck into the presentation. If you could share your screen with us. And just a reminder to everybody that you can please send us your questions through using the Q&A tab at the bottom of the screen. And the session is being recorded, and the presentation will be available on the Teagasc website afterwards. And also we have the live transcription switched on there, and if it is useful to you, you can leave it switched on. Otherwise, you can hide it there if you find it's interfering with the presentation. So James, I'll hand over to you.
Okay, thanks, Mark. You can see my screen?
Yes, looks perfect.
Okay, good morning, everybody. As Mark said, the title is Commercial Dairy Farming Without Fertilizer Nitrogen, and there's a question mark, and it's I suppose a somewhat provocative title. And the question mark, as Mark already said, is why you do such a thing. And it's down mainly motivated by trying to improve the environmental performance of the farm. So if we look at fertilizer nitrogen recommendations over the years, we see if we go back to the early 1990s when I started working for Teagasc, the recommendations range between 250 kilos per hectare at 2.5 cows per hectare coming from Johnson Castle, and up to 380 being recommended by Moorepark. And as some of the subsequent work we did, Kay O'Connell's PhD thesis was to show that some of this difference in recommendations was down to differences in soil type and where the experiments were conducted. Johnson Castle having much higher background release of nitrogen than Moorepark, and Moorepark with its light sandier soils, very responsive to nitrogen fertilizer in input in terms of grass growth. Of course, then during the mid-2000s, 2006, we had the introduction of the nitrates directive. The fertilizer used in is kind of limited to between 250 and 280 kilos of nitrogen per hectare. And there's been a lot of improvements in fertilizer management in the intervening period in terms of rates and dates of fertilizer nitrogen application, how we manage slurry, how we integrate slurry into the system. And the current recommendations are for between 150 and 250 kilos nitrogen per hectare. And this depends to a large extent on the inclusion of clover in the swards, the lower rates being recommended where there's plenty of clover in the sward. What we've been doing at Salahead, we've been looking at clover now for nearly 20 years. We're now down to a situation in 2020 where we use around just less than 100 kilos of nitrogen per hectare, stocked to 2.5 cows per hectare across the farm. And our target is to go lower than that. And our motivation for this is two projects. One of them is funded by the Department of Agriculture called Lowering the Carbon and Ammonia Footprints of Pasture-Based Dairy Production. And that's really particularly the carbon footprint. We're aiming at how low can we go in terms of lowering our emissions. And the second project then is Teagasc funding, developing a blueprint for low or zero nitrogen fertilizer input for low emissions pasture-based dairy farming. And of course, both of these projects are integrated and overlap to some extent. If we look at nitrogen fertilizer use since the 1930s, we can see that there was very little nitrogen fertilizer used in Ireland prior to World War II, and this is because it wasn't really available. It was only after World War II when oil became cheap and freely available that we see a big increase in manufacturing nitrogen fertilizer internationally. The manufacture of nitrogen fertilizer is very energy intensive. And this coincided with a large increase in the global population. And if we take the time frame encompassed by this slide here, going from 1930 to 2020, the world population quadrupled in this period, going from around 2 billion to almost 8 billion. And the big concern, particularly when I was young, when I was not much older than the child there in that picture, during the late 60s, early 70s, was this concern with the rapidly growing world population, which was growing very rapidly at the time, and the concern was how we'd feed the planet. And not only in Ireland, but we see internationally a big increase in nitrogen fertilizer use. And when people think about the things that have sustained this very rapidly growing population that we've seen, nitrogen fertilizer has been a key player in that. People often think about sanitation, better medications, antibiotics, and these kind of things, but nitrogen fertilizer has been a key driver in feeding a growing world population. And a lot of the concerns there were about mass starvation really have been alleviated, in that we've seen a huge increase in global population without actually the food security has declined to very low levels. Less than 10% of the world's population now would be at risk, compared to more than 50% in the 1960s. So we've seen a very much improved situation in terms of global food security, and nitrogen fertilizer has been a key driver of that. And of course, when you start talking about cutting nitrogen fertilizer use, you have to be very conscious of these changes. If we look within the European context, like we often forget that World War II was one of the motivating factors for that was in Japan and Germany, concern about how they were going to feed their populations. And acquiring more land was part of their expansion agenda at the time. And during the war, German farmers, or the German government, paid French, Dutch, Belgian farmers to increase their food production. Food security was a big problem in Germany. Likewise, in the United Kingdom, the governments there paid their farmers to increase their production. And really, it is those payments to farmers are the basis for what our current CAP, or Common Agricultural Policy. Didn't have much impact in Ireland until we joined the EC in 1972. And it's following the joining the EC that we see a huge increase in nitrogen fertilizer use in Ireland, until we had the introduction of the milk quota in 1984, which we see some bit of a tailing off in fertilizer use after that, because of there was excessive milk production in Europe, so there was the introduction of the milk quota. We still had an increase in livestock numbers in Ireland, primarily beef and sheep, subsequent to the introduction of the milk quota. This is a period of where we coupled payments for beef and sheep production, the McSharry years. This went on up until the late 90s, Franz Fischler, and then we see a reduction in fertilizer nitrogen use, which coincides with this whole policy of decoupling and extensification. So fertilizer nitrogen has been strongly influenced by policy decisions. So there's a substantial reduction there between around 1998 and 2011. And since then, we've seen an increase in fertilizer use, I suppose somewhat driven by the abolition of the milk quota and increasing dairy cow numbers. And now we're moving into a new policy area, new policy agenda, the Green Deal, which one of the aspects of that is a 20% reduction in fertilizer nitrogen use, as Mark has already outlined, which again is one of the motivating factors for this work. I suppose the other thing is, if we look at greenhouse gas emissions per capita in selected European countries, you see that one country immediately stands out, and that's Ireland. And we stand out because we've very high emissions from agriculture. If we look at this from agriculture relative to other sources, if we compare across European countries, Ireland has a very distinctive emissions profile. And the second thing that this slide shows us is that we have high emissions per capita, and on a global basis, global scale, we have very high emissions per person compared to many other countries. And say if we compare ourselves to our near neighbours in the United Kingdom, for example, 7.5 versus 13.2 in Ireland, much lower emissions. Denmark, with a similar size country and population, also fair dependence on agriculture, substantially lower emissions. And then if we look at the frugal Swedes with their very, very low emissions, so compared to Ireland. So we are in the spotlight to some extent in this country in terms of meeting our emissions reductions target. And agriculture in particular because of the large contribution that it makes to our emissions. If we look at emissions profile on a intensive dairy farm, this is a selection of intensive dairy farms, high stocking rate, high fertilizer nitrogen use, around carbon footprint about 1.05 kilos of carbon dioxide equivalents per litre of milk. Large portion of that coming from enteric fermentation, methane, biogenic methane. Nitrogen fertilizer is also a big player, concentrates and excreta. And if we look at, say, the things that we can do on a farm, we can improve this enteric fermentation by improving our EBI, better production, lifetime production from dairy cows, lower replacement rates. And in terms of slurry management, low emission slurry spreading. But a large amount of the manure produced on pasture-based dairy systems is outdoors, so the less doesn't really come into it. And really, I suppose the point of this dividing line is that everything to the left of this line depends on to the right of this line depends on livestock numbers. And we need dairy cows to produce milk, and we need replacements to replace those dairy cows. And then we really can work on this end of this side, on the left-hand side, particularly in nitrogen fertilizer use, where we can use different techniques to lower our fertilizer nitrogen input or lower emissions from fertilizer through use of protected urea, for example, or the use of clover. So as I said, these are the two projects that we're working on. It is based on earlier work that's published, work conducted between 2000 and 2010. And what I'm going to talk about today is work we've done since 2010. But prior to 2010, we were comparing clover-based and nitrogen fertilizer-based grassland for dairy production. What we found was no difference in profitability, as we were saying to Mark already. And this, of course, isn't a very strong incentive to adopt the system. Of course, this was in the context at the time of milk quota situation and the REP scheme, the Rural Environmental Protection Scheme. What we did find, even though the focus of our work at the time was primarily on water quality and lowering nitrate leaching losses, but we also found that we got substantially lower greenhouse gas emissions, 16%. And that was really without focusing too much on that question. It was more by accident than by design. So the current work that we're looking at is to seeing to what extent can we go beyond this 16% reduction. Now, if we look at fertilizer nitrogen response curves, and I suppose the reason I'm leading into this is that a big focus of our work is on nitrogen fertilizer as a means of cutting our emissions. If this is our response curve, we normally find that we grow maybe around 6 tons of grass with no nitrogen at soil ahead, going up to 15 tons with 280 kilos, 300 kilos of nitrogen per hectare. And what's happening below here is that we're getting the 6 tons from background release of nitrogen. This is nitrogen that's being turned over in the soil, and all soils have a capacity to release a certain amount of nitrogen over the course of the year. And of course, I talked about differences in recommendations in the past, and this is largely down to different soils and their capacity to release this background nitrogen. At least this is the situation for soil ahead, and we look in when we apply nitrogen fertilizer, this really gives us this response that we see, this increasing production that we get from nitrogen fertilizer input. So that's a nitrogen fertilizer response curve. If we then introduce white clover into the system, we get a different type of response curve, intersecting here up at around 15 tons per hectare. This is based on system scale studies. These are full system scales with around 24 cows per system. So the full system scale, 7 years using 280, 1 year with 250 kilos of nitrogen per hectare. This system here, which is our more or less standard system, clover-based system, with 110 kilos of nitrogen per hectare. We've 10 years of data since 2010. And then the zero nitrogen system that we've been looking at more in recent times, we've 3 years of data on that, so there's a little bit more uncertain about this system. When we look at the difference between these two lines, really it's down to biological nitrogen fixation, and this graph tells us a number of things that as we, like our clover contents here are around 10%, clover contents here of the swards are 22% or so, and the clover contents that we're looking at on these swards are in excess of 25%. So as we increase our fertilizer nitrogen input, our clover contents go down, and our biological nitrogen fixation goes down. Or if we reduce our fertilizer nitrogen input, we get an increase in biological nitrogen fixation, around 150 kilos in this case. And where we go right down, we can get up to in excess of 200 kilos of nitrogen per hectare being fixed, which of course is a key driver of productivity. And that's why this line is much flatter than the line where there's no clover. And of course, the key to this whole thing is that when we exchange, or if we reduce nitrogen fertilizer input and replace it with using biological nitrogen fixation, we get no nitrous oxide or ammonia emissions associated with it. So that gives us a big potential to lower our greenhouse gas and ammonia emissions, because nitrous oxide is a very potent greenhouse gas. Even though we lose relatively small amounts of it, it has a very high global warming potential. And in that way, it has a big impact on emissions from a farm. I think when you look at data like this, you often like to look for confirming data, but this is again a response curve from grass clover swards from work conducted at plot scale in Moorepark by Daniel Enriquez Hidalgo, who did his PhD thesis with Deirdre Hennessy. But you can see the response curve is very similar to what we're seeing in Salahead, which kind of gives us confidence. So I talked about targeting systems or designing systems where we're actively seeking to lower our emissions. So what can we do? We can improve soil fertility, which is key in terms of lime use, P and K. Use of protected urea will help to lower emissions compared to, say, CAN, for example. It will lower ammonia emissions compared to straight urea. If we integrate white and red clover into the swards, as I said already, we're relying on biological nitrogen fixation, where we can take nitrogen out of the system and replace it with biological nitrogen fixation, which takes place in the root nodules here. That will help to lower emissions, improving EBI, low emission slurry spreading, as I said already. So how does this impact on our systems? And as I said, these are mainly run at systems with 24 cows per system. And what I've done for this purpose for comparison is to scale it up to a 50 hectare farm and to look at the impact in that regard, including profitability. So if we take three stocking rates, these are the kind of stocking rates we can sustain with the different inputs. Clover-based system, both of these systems are clover-based systems. In this case, we've optimized everything, say, in terms of the EBI of the herd. So we've picked our best across each lactation number, and by blocking the cows and calving date and lactation number, we put our best cows across each lactation onto our low carbon herd, as we call it. So these two herds are similar EBI. This is higher EBI. 50 hectare farm, this is the number of cows. We look at our emissions per litre. You can see the emissions reductions that we're getting from the systems, going from 0.88 here down to 0.69. If we include sequestration, which is often included in the models, we can see we're getting even bigger reductions. Even though I'm hesitant to include these figures, because we've been measuring soil carbon at Salahead for nearly 20 years now, going back to 2001. And what we found is that we're storing a huge amount of carbon in the soil in Salahead, around 200 tons per hectare in the top 90 centimeters. What we haven't found is evidence of any large increase in that over this period in terms of sequestering additional carbon. And I suppose looking for this sequestration, it's probably taking place, but it's probably taking place at a level that's difficult to detect against the background of the huge amount of carbon that's in the soil already. And I suppose it's a bit like looking for a pot of gold at the end of a rainbow. It's very difficult to find, probably because it's relatively low. So these are the emissions per litre of milk, which is one metric you can use, and it has its benefits in terms of, say, the marketability of products. Obviously, if we have a much lower emissions here, it's more attractive from a consumer's point of view if you want to buy a product with a lower emissions profile. If another way of looking at it is per tons of carbon per hectare, and we can see the reduction that we're getting in that regard. I suppose the interesting thing here is that each hectare of soil, or each hectare of the farm in Salahead, is giving us the emissions that are almost equivalent to the emissions per capita in Ireland that I showed already. If we look at ammonia emissions, we can see also substantial reduction in ammonia emissions when we take fertilizer nitrogen out of the system. Fertilizer nitrogen being an important source of ammonia emissions. And if we look at this relative, say, to the national average, as I put forward already, of 1.05, we can see even with our intensive system, we're getting a reduction, but up to 34% reduction as we move across to the low emissions, the low carbon system, low fertilizer nitrogen, high EBI, low emission slurry spreading, where we're optimizing everything in terms of aiming for low emissions. We also looked at the net margin, and we're surprised to see that we had increasing net margin with a lower fertilizer nitrogen input. So when we're optimizing everything, we can get higher production or higher profitability. And just to look at that in more detail, so the same scenarios as I laid out already. We look at milk sales, they decline with cow numbers, with stocking rate, but compensated to some extent by higher output from our higher EBI cows. We look at our total sales, they are lower, but then if we take into account our variable costs, we see substantially lower variable costs. Fertilizer nitrogen makes up a large part of that, accounting for around 12,000. We also get other reductions in terms of, say, if you have lower cow numbers, you make less silage, you have less slurries to handle, these type of costs. With the clover system, we've higher reseeding costs. We've doubled the rate of reseeding compared to essentially our non-clover system over here. So we've factored that in. And then if we looked at our fixed costs here, you can see similar enough fixed costs. What's included in this fixed cost is the labor cost based on 27 hours per cow at €15 per hour. So there's a labor cost of around 50,000 in each of these systems, giving us an increasing net margin with the lower fertilizer nitrogen input. So it's quite competitive, quite favorable in terms of net margin. If we factor in the 50,000 paid out in labor, you're talking about potential family farm income of between 120 and 130,000 on a 50-hectare farm. It's a very attractive proposition. And then, as I've shown already, the increasing net margin with a lower input system. I think that that's a very positive story. And I suppose the question that comes up is how has it impacted on our carbon and ammonia footprints? And I think one of the ways to examine that is to look at what's happening on the farm at Salahead as a whole. And if we go back to pre-quota times, so back to 2011, 2013, at the time we had 90 cows on the farm. We have a 130-acre farm, around 52 hectares. Half the farm at the time was under clover, receiving low rates of nitrogen, and the other half was an intensive system getting 280 kilos of nitrogen per hectare. We were rearing our own heifers on the farm, producing just less than 40,000 kilos of milk solids per year off the farm, with a carbon footprint of 9.7 tons per hectare and 0.82 kilos per litre of milk. And our ammonia emissions are there. Then in 2015, we increased cow numbers, and in 2016, we had around 125 cows on the farm. We upped the fertilizer nitrogen use. Stocking rate of 3.9 cows, 2.39 cows per hectare, and we increased our milk production. And that was after consultation with Tip Co-op, who owned the farm. Prior to the abolition of the milk quota, they asked us to increase our milk output from the farm by 50% in line with Food Harvest 2020, and to see how that could be done. And in our case, it involved changing around our housing system, bigger bulk tank. We bought a new milking machine, and also we started contract rearing out the replacement heifers. So that gives us scope to increase the cow numbers to 125. That obviously had an impact on our carbon footprint per hectare and per litre, and also our ammonia emissions. And then in 2017, we started on the current work, looking at actively trying to lower the emissions on the farm. And you can see the changes that have taken place. We're down to around 100 kilos of nitrogen per hectare across the farm. You can see the stocking rates and the milk output. And you can see the reductions that have taken place that coincide with lower fertilizer and nitrogen use. And whereas we have not lowered our emissions per hectare relative to our baseline here, we have in terms of per litre of milk. And I think there needs to be a small bit of caution used in terms of metrics used for assessing farms. Carbon footprint per litre of milk is often the metric that's used. You can actually reduce your emissions per litre of milk without impacting on your carbon footprint per hectare. And I suppose this brings us on to the current system, or the direction of travel. That's all ahead, where if we move in this direction, this will actually get us back to where we started. Also lower emissions per litre of milk and lower ammonia emissions compared to our baseline. And that's having increased the milk production on the farm by 50%. So that really has to be an important consideration in this. We're talking about having increased milk production by 50%, but maintaining similar level of emissions to pre that expansion, which is a very positive achievement. And I suppose in terms of meeting our targets for 2030, the type of practices that we're employing on the farm will have an important role in achieving those 2030 targets. Now, clover is a key component of what we're doing, and the question always comes up: how do we optimally manage clover swards, particularly for low emissions dairy farming? And low fertilizer nitrogen input is key. The less nitrogen fertilizer we put on, the more nitrogen we'll fix, because when you start putting on high nitrogen, it drives on grass production, which often competes with the clover in terms of space in the sward. And it also tends to prevent nodulation and nitrogen fixation in the roots of the clover. So the less nitrogen fertilizer we use, the more fixation we'll get, and the less ammonia emissions we'll get, and lower nitrous oxide emissions, as I've said already. So low fertilizer nitrogen input is key, and managing that is we're working on decision support rules around that, because you need to have a flexible approach to this, but minimizing it is key. Tight grazing is also very important, and if we look at our productivity on the farm prior to 2010 and subsequent to that, when we did some work between 07 and 09 on post-grazing height, tight grazing has a very big impact on clover productivity. And the tighter you can graze your sward, the more productive it'll be. It almost sounds like a contradiction in terms, but less nitrogen, the better. The tighter you graze it, the more productive it will be. Soil pH is very important. Nitrogen fixation is a biological process. So if you don't have your soil pH in good order, you won't get the levels of fixation that you need. And also, we think regular applications in P and K is very important, particularly on farms that are deficient in P and K. And that's because when we look at the root volume of clover in the soil, it only accounts for maybe 12 to 15% of total root volume, compared to 80%, 85% from grass swards, the grass component of the sward. So we often think about competition between grass and clover in terms of competition for light, but there's also competition going on beneath the ground. And the grass is extremely competitive from that point of view. So regular applications of P and K are important to assist the clover. Of course, this argument ties in as well with the low nitrogen input. When you lower the nitrogen input, you're also favoring the clover because it has this capacity to supply its own source of nitrogen. What we found is increasing to 6-week rotations in the autumn. Tight grazing is important during the year. As you move into the autumn, you can start extending out your rotation. And this helps to build clover stole on in the run up to the winter. Like the main clover is most dominant in the sward during the summer. You get a big increase in the clover content, but also in the amount of stole on mass that's growing at the base of the sward. Because clover grows very much, if you wanted a good analogy, it's like ivy growing up a wall. It has these stolons, which are the stem of the ivy that grows up the wall. These grow along the surface of the ground and sending up leaves at intervals. And having a good mass of stolon is important for this long-term survival of the clover. and it's most at risk at loss over the winter period. And with bad management, we've measured where with poor management decisions, we could lose maybe 75–80% of the stolen mass over the winter period, which of course puts you in a very bad position then in the following spring. What we found is low covers over the winter has a very positive impact on stolen survival by allowing more light down to the base of the sward over the winter, even though this recommendation then conflicts with the objective of carrying high covers over the winter for early spring grazing. So this is a recommendation that would contradict or conflict with current grassland management practices, and it's something that needs to be changed, and it's something that needs to be assessed in terms of the impact of that. Reseeding is important, more for the clover than for perennial ryegrass in our case. Regular reseeding we see is important, and we often get questions about managing clover on wet soils, and Salahead is a relatively wet farm. Of course, we've done an awful lot of drainage over the years, and we do a certain amount every year, maybe spending 4,000 or 5,000 per year on improving our drainage. And that's something that I would say encourage farmers very strongly, that if you're on a wet farm, you really need to invest in drainage, and big improvements can be made at relatively low cost. And in terms of the capital investment on a farm, you'll never regret a well-designed drainage system. And I say well-designed because you really need to get in experts that know what they're talking about in terms of how to optimally put in your drainage system. You know, the people in Moorepark that can assist with that. And then some other things that we found is often where you have very productive clover swards, you get a buildup of nitrogen in the sward over time, a buildup of nitrogen in the soil. This tends to favor the grass component of the sward, and this can be managed by taking off a heavy cut of silage. If you take off 5 or 6 tons of dry matter per hectare, you're taking off around 150 to 180 kilos of nitrogen per hectare. And mining out that nitrogen, taking it away, putting it in the silage pit, that then leaves the clover, if the clover is under pressure, it leaves the clover in an environment that's more favorable to its expansion. So there are techniques that we can use to maintain the productivity and increase the productivity of our swards, and that's something that we'll continue to work on. So in terms of wrapping up, when we look at dairy systems across Europe, and it's something I've been doing now for a long time, for 20 years, different projects, we find that we compare very well in terms of our many metrics in terms of environmental performance of our dairy farms. Where we tend to fall down relative to other European countries is in the use of nitrogen fertilizer. And that's because in other European countries, they've moved away from grassland and often have maize as a major component of their farming systems. And you can grow huge yields of maize with very relatively low nitrogen inputs compared to grassland. You grow 15 to 20 tons of maize with 150 kilos of nitrogen compared to, say, if we want to grow 15 or 16 tons of grass in Ireland, you need to use a maximum 280 kilos of nitrogen per hectare to get close to that. However, if we start looking away from nitrogen, in our case, we have a natural advantage in being able to harness biological nitrogen fixation into our system. And that's through the use of clover. So when we can integrate it into our swards, which is our main source of feed, we can do that. We have the climate that suits doing that. And if you say compare it to a Dutch system, for example, reliant on maize, it's much more difficult to integrate nitrogen fixation into your rotation. You'd have to include it in a kind of a tillage rotation. Say, we can do it much more effectively in a grass sward. What we've been finding in Salahead, we can have a high stock system with low environmental footprints. We have a very low impact on water quality. We can lower our greenhouse gas emissions by around 35%, as I've shown already. Also, we can lower our ammonia emissions. And it's also an economically competitive system. So whereas the economic argument for clover may not have been as strong in the past, I think with improved productivity, with better management, and also the changing conditions in terms of requirements for environmental performance, I think it becomes much more attractive system. And clover, less and protected urea are the things that we can use to lower our emissions in terms of meeting our 2030 targets. If we look beyond 2030 targets, and say to 2050 and trying to achieve net zero emissions, I think this really is an enormous challenge. And I think I spoke earlier about how policy can impact on our decisions in terms of nitrogen fertilizer use, on livestock numbers and everything else, but indirectly on nitrogen fertilizer use. I think we have to be very clear about the policy decisions that are made now, looking forward to 2050, because I think offsetting is going to be very important in terms of increasing forestry, in terms of offsetting our emissions from agriculture. And this, I suppose the gut reaction thing would be to say, well, we'll cut emissions from agriculture by cutting our production, or by, and this mightn't necessarily be the best way forward. And I think there's a strong argument for actually intensifying the production system along the lines that I'm talking about here in Salahead, making more land then available for offsetting in terms of forestry. And we have to be very careful, because food production is an important business in Ireland, and we have to be careful not to kill the golden goose. Also, I think if we can work on lowering our emissions from food production with low environmental footprints, there's good marketing opportunities for that. So that's my presentation, Mark. I'll hand back to you now in terms of the questions.
Thank you, James. Excellent presentation, and really you've triggered a lot of really good questions here from our audience, and special welcome to our people from we've people from Dundalk to Dusseldorf tuned in this morning. James, you'll be delighted to hear. So a lot of interest in your presentation this morning. Just from my own perspective, James, you mentioned the carbon sequestration, and what I'm hearing from you is an air of caution around the our maybe, I would say, reliance on additional carbon being sequestered by our soils. Am I hearing that correctly?
Well, I can only speak about Salahead, because my experience is limited to that. I think we set out with great enthusiasm 20 years ago to show that that we could offset some of our emissions from the farm by looking at our sequestration in the soil. We knew that we had very high levels in the soil. It's just the nature of the soil in Salahead. And what we found, I suppose, that there isn't, we're not finding a large amount of sequestration taking place. And I suppose when you look at a dairy system, a grassland-based dairy system where you're cultivating, where there's reseeding going on, we know that when you reseed, that you lose carbon out of the system. You get mineralization of the carbon that releases carbon dioxide. And what we found is, over the following years, we're actually sequestering back that carbon. So maybe after 10 years, we're back to square one in terms of our total carbon balance in the soil. So what we are happy to say is that in terms of the system, in terms of the soil, or the system that we're running, that we're carbon neutral from a soil point of view. We're neither losing carbon from the system or sequestering carbon. Bearing in mind, we're reseeding, we have been draining. Question often comes up, are we losing carbon when we're draining? We're not finding that. But we've finished the project, we 2 PhDs have worked on the question of drainage and soil carbon and what our greenhouse gas emissions, and what we found is that by draining, we lower our nitrous oxide emissions, because nitrous oxide emissions are often dependent on wetness. The wetter the soil, the greater the emissions. So by draining, we can lower our carbon footprint by lowering nitrous oxide emissions. So I've kind of deviated a small bit from your question, but the short answer is we're not finding a lot of sequestration. And as I said in the talk, it's a bit like looking for the pot of gold at the end of the rainbow. It'd be very nice to find it, but it's very hard to find it.
Just before we go to questions, and I'm conscious time is ticking on, but just to make people aware that Teagasc does offer, through the Connected Programme, training to professionals around the whole area of land drainage, because we know that there are so many, different solutions to different types of drainage issues. So our colleague Pat Toohey leads that, and it is an excellent course which should be delivered next year. We're not in a position to deliver it this year. Pat, some excellent questions coming through there. I think we'll try and get
Fine.
through as many of them as possible, because there's quite a lot coming through. So if James, you could try and provide as concise an answer as possible. It would be nice to try and get us through as many as we can.
Okay, I suppose first one, that we've had a couple of sessions on multi-species swards, and there's a question in there: what's the potential for herb species, plantain chicory, for carbon sequestration? And I suppose within your own drive to zero nitrogen, has it a potential role?
I think the way we've looked at it is in terms of nitrogen fixation, and if we're looking at other species that we integrate, we really want to integrate more nitrogen fixing species rather than other herb species. I think there are, as I said before, there is work going on this, and I'd be more inclined to wait and see what's coming out of this work before we'd go in that direction. Like, I have the impression, I think that chicory doesn't last very long in swards. So it doesn't seem that promising. Plantain may have more to offer, but from our point of view, as I said, there's enough work going on without us looking at it. And from a zero nitrogen point of view, like I've read papers that show that there may be some advantages in a low nitrogen situation, that chicory may be more productive under low nitrogen situation. When you look at the level of production that they're getting relative to what we're getting, it's not that attractive.
I suppose a big question here is just saying super talk and just saying that the focus on nitrogen really makes room for methane from animals. But what's your vision for a climate neutral dairy farm? Is that something that you see out there? And I know you've taken on the really hard challenge, but I suppose that the next phase of that challenge is that question of carbon neutral.
You see, I suppose the way I'd answer that question is, if we were to approach carbon neutrality using existing technology, what we really have to look at is offsetting on a large scale nationally. So that would mean, like, if we say in Salahead we're losing 10 tons of carbon per hectare, we know that an average area of forestry will sequester 5 tons per hectare within a 40-year time frame, say, as the forestry is growing. So if you were to say right now, put the gun to the head and said, right, you have to achieve carbon neutrality, what you're looking at is substantial amount of forestry, and of course this is well known. And it's something like that would buy us time until new technologies come along. Like, I think there is the issue of, say, using methane inhibitors. I think probably they're 10 or 15 years away from what I'm hearing. And then there's the whole question of whether they'll be acceptable. But we can't preclude the idea of new technology coming on. And I guess if I used the analogy earlier on about the big challenge for my generation was food security, that has largely been solved. I suppose education, contraception were big parts of that. When some of those earlier analyses were being done, those kind of things weren't really conceived. I know I'm going off the point now again. Okay. I think in terms of, if we were to say dealing with current technology, you'd say forestation, and to achieve that, and this is a point that's easily missed, we really need to intensify our agricultural production rather than extensify it. Like, we have a lot of extensive farms in the country that are taking up a lot of land. We pay those farmers to extensify, it actually makes it more difficult to achieve carbon neutrality than this idea of sustainable intensification, which people don't like that expression. And it's often been a kind of a green, being accused of a greenwashing kind of an expression. But the reality is that's a misunderstanding of the concept. Like, in Salahead, we can maintain our output, cut our emissions by 30%. Then the next step is to look at offsetting, which is something very difficult to do within the farm boundary. So you're looking at outside the farm boundary in terms of policy, national policy. And I hope I've answered the question clearly.
Okay. Yeah, no, I think you've done a good job. A question there in terms of methods of reed seeding and with the management you have there, are you able to achieve a good quality sward on an ongoing basis with potentially stitching in, or do you need to actually go for a complete reseed at certain times?
Yeah, I suppose if we look at the work we did earlier on in the reps type scenario, we used stitching in and oversewing and things like that, and they're a bit, as people would say, hit and miss. It depends a lot on the weather. Often it depends more on the management afterwards than before, and getting that management right. It's a bit, and I think that's fine if you're dealing with a relatively extensive situation, but if you move into a more intensive dairying situation that we're dealing with at the moment, you really need to be looking at reseeding, integrating reseeding into the system. And I think, yeah, absolutely, reseeding is the way forward. In terms of reseeding, we disc, we burn off a glyphosate disc and power harrow. It's straightforward.
Okay, there's a couple of questions in there in relation to water quality issues and loss of nitrate. Now, I know Solid is a fairly heavy soil, so probably not a major amount of nitrate loss, but just in terms of a general comment, in terms of the, I suppose, the replacement of chemical nitrogen with plant produced nitrogen, and what the impact it might have on water.
Yeah, so for similar levels of productivity, if you look at the lost pathways, when we put on nitrogen fertilizer, and like I know that the idea is out there that we use nitrogen fertilizer with an efficiency of around 25%, but when we put on nitrogen fertilizer, we actually get most of that taken up by the sward, 90%. So it's only when the cows then graze that grass, put the nitrogen through the digestive system, and they deposit it out in dung and urine. That's your lost pathway. So urine patches are an important lost pathway. Now, whether we use nitrogen fertilizer or whether we use clover, like we're supplying more or less the same amount of nitrogen. We're putting more or less the same amount of nitrogen through the cow. So the potential losses there from clover-based system are somewhat similar to the potential losses to water from fertilized grass-based system. So there's clover gives a big advantage in terms of ammonia and greenhouse gases, not so much in terms of leaching. However, when you take nitrogen fertilizer out of the system, you then have to focus much more on optimal management of your slurry and your dirty water, which becomes a key component of your system. When you're forcing yourself into that type of scenario, they become much more important, need much better management, and I think we'll see the improvement in water quality in that regard. Now, if we look at water quality and issues there, I suppose that you could always again point to nitrogen fertilizer being a problem. Obviously, it's a contributing factor, but probably dirty water slurry management on farms is probably an area where there needs to be more focus. And as I said, when you take nitrogen fertilizer out of the system, that becomes becomes much more important to manage those optimally. And I think for us in Salahead, really, we need to, we'd like to see maybe bringing in more, improving our slurry storage, improving our dirty water storage, in that we can use it more effectively to improve the productivity of our system.
There's a number of questions there in relation to what one person says, going the next step and going for an organic production system, which obviously then will take out some of your P's and K's. How challenging do you see that, or do you see scope there or relevance for your research?
I think that it would be a mistake to kind of conflate what we're doing with organic, because so we have a no nitrogen system, but it is a long way from organic. And as the person said, P and K, use of herbicides, these type of questions. And I think the organic question is purely a marketing question. Once the markets are there, which they appear to be, and we get processors to develop those markets, I think we would have a good potential relative to other countries to run organic systems. Because, as I said already, the climatic advantages we have in terms of grass growth, in terms of being able to integrate legumes into those grass swards, I think I think we'd have a competitive advantage. It's amazing in a way that we haven't. When you see the growth of organic dairy production, particularly in other countries, you'd say it's amazing that we haven't gone further. And I think it's a very interesting question, the whole organic question. But it's different to what we're doing. Like, we're still running a fairly intensive system without fertilizer nitrogen. That's the key difference.
James, there's a few questions coming in around the how applicable what you're doing in Salahead to more northerly parts of the country, less intensive parts of the country. Well, I suppose dairying in other parts of the country as well, but question here, what's in this for farmers based in Cavan and Leitrim and Longford and Monaghan and those parts of the country? Can lessons from Salahead be applied?
Of course, and I know that Ballyhaise are now changing over their farm to a clover-based system, and we've been talking to them. And like, when I go up to Ballyhaise, people often say the disadvantage north, but I think Ballyhaise is a much nicer farm than Salahead in terms of wetness and the difficulties that we have. A month ago, we were splashing around the place. So, like, Salahead is a farm. Like, it's a good capacity to grow grass, but it has limitations, like a lot of other farms, in terms of drainage and things like that. And even with the drainage we put in, we still have problems. So I don't really see, like, we get variable soil conditions around the country, variable growing conditions. I think it'd be very interesting to see what happens up in Ballyhaise and how that works out. But I'd be confident that they won't have any difficulty doing what we're doing.
Okay, there's I suppose a fairly practical question. Is bloat a problem in the animals, or has it been observed over the years?
Yeah, so we've been running clover systems for nearly 20 years, and we had no cases of bloat until October last year, and we lost 3 cows over one weekend. So that was a big shock to the system, and I suppose what we put it down to all along was the fact that we don't have particularly high clover contents because of the nature of the soil that we have in Salahead. Partly put it down to the cows get conditioned to clover when they're on it all the time. And aspects of our management, like the high risk period is during the summer, when we tend to, late summer, autumn, when you're very high clover contents, when we tend to build up higher covers which have a bit more fiber in them. Now the case of bloat that we had last October, kind of beyond the risk period, if you know what I mean. So maybe there's a bit of complacency had slipped in there, but I think weather conditions also influenced it. So we've put in system now for ensuring that there's bloat oil in the water, because we just don't want to take the risk of that. Now, there's a cost with that, but when we look at the potential savings, it's justifiable. And also, like, one of the next areas to target from our point of view in terms of cutting emissions is the concentrate use, which we've been feeding to some extent to maintain our magnesium, to avoid grass tetany. But with this system now, we can, that will actually allow us to cut our concentrate input and cut our emissions accordingly. So it's a kind of a thing that came out of the blue and could work for us.
A couple of questions.
We're going to have to cut it there, I'm afraid.
Okay.
We are at 10:30, and we'd like to try and confine it to the hour, because I understand people have other plans after 10. But James, thank you so much for an excellent presentation and your candid responses to the questions as well. We could nearly do an after show with questions, and maybe look, we continue to keep an eye on what's going on in Salahead, and hopefully we'll see some events happening in Salahead. Maybe there'll be an opportunity for our viewers to visit Salahead in the near future when COVID restrictions start to relax. Maybe you have some. I'm sure you're keen to get people in on the farm.
Well, we've groups visiting all the time, so we are open for business in that regard.
Yeah. Great. Good to hear you. You could be sorry, James.
Yeah.
Very good. Look, I want to thank our production team, Yvonne Maher and Andy Boland, and of course our partners. And Pat, thanks so much for your help with all of the questions. Lots of really good questions coming through. And of course to our viewers, thanks for tuning in. And next week, we're going to be joined by Dr. James Moorepark, who's going to be speaking to us about high nature value farmland in Ireland, marginal farming, or a central role in combating climate and biodiversity challenges. So we do look forward to be joined by Dr. James Moorepark. So with that, we leave you, and we hope to see you next Friday morning, and enjoy the fine weather. I hear we're having a bit of fine weather coming our way over the next few days. So hope you get to enjoy it. Thanks very much.